Hey there, kids. I hope you're ready for another lesson. This one is Module 1, Lesson 14. And we are going to be doing a really big, important skill today, and that is dividing with decimals. So the objective is to divide decimals with a remainder, but the important thing to understand is that place value still plays a really big role in this operation. And we're going to connect to a written method. So unlike previous lessons where we're just talking about concepts or the conceptual approach, we're actually going to use the standard algorithm, which is a lot of fun and it's a big part of your future in math. So we really need to lock in this skill. So here are a few notes to help you practice or at least describe the method. So what's going on here? We're going to take a whole number and a decimal fraction. So we're going to have decimals, numbers with decimals, divided by whole numbers. We're going to keep it simple in the beginning, only working with whole numbers. We will use a place value chart. The place value chart is going to have the place value discs showing the numbers. So take 6.72 or 6 and 72 hundredths. And then in the same way that we've learned to understand that each number in a higher place value position has 10 times the value here that a number to the right does, when we divide using the standard algorithm, we start over here in the bigger place value positions and we work our way to the lower positions. But why do we do it this way? Because what happens with the remainders is that we're going to regroup numbers so that you have more to divide with in the lower columns. Okay? So once you take, I know this one's already done, so we'll just talk through it real quickly. The 6.7 dots and then 2, that's the only thing you would have at the beginning. Then we start to share. So division is sharing. And so in the word problems, you'll often see share evenly, shared with friends. They all had the same amount. And so when you see those key words, what it means is there's likely division happening, because if something is like repeatedly being subtracted, that's division. So 3 is going to be the number of sets that we're dividing it into. And what are we dividing? We're going to share the 6 divided by 3. So when you count it, you're going to go 1, 2, 3. We're going to count evenly. And we will only distribute as many as we can until we have extras. Now the extras we're going to regroup. One of these is worth 10 here. That's why we have so many dots in this hundredths place, because one of these was left over after sharing all 7 of those. 1, 2, 3, 4, 5, 6. The 7th one gets regrouped as 10 of these. And then I can take my 12, which it was a 2, but now it's 12, and I can evenly divide it by 3 to get 4 in each place value position. So that's what's happening here with the visual model. In the standard algorithm, we have a couple different things that are very important. Hopefully we'll have done this in class if you're in my class, and if you're not in my homeroom class, then if you're just an online student, remember that this is where the division family comes in. And the division family is just kind of a traditional way to remember the D for divide, the M for multiply, the S for subtract. The C, a lot of 4th graders don't know this coming up to 5th. The C is the cousin, just as important in here, to compare. And it's not an active writing step, but it's an active thinking step. It's very important. And then B for bring down. And we repeat until we're finished. So we might do this 3 times in a problem like this until the division family is completed. Okay, so let's get into it, and we'll actually apply these skills in lesson 14. So in your Learn book, mine's on page 97. Hopefully you're on page 97 as well. It says, draw place value discs on the place value chart to solve. Show each step using the standard algorithm. So we're going to connect these two methods. So first of all, the fun part is taking this number or these digits and putting the dots where they need to go. Easy peasy. 4 in the ones place. 1, 2, 3, 4. 2 in the tenths. We have 2 tenths. We have 3 hundredths. 1, 2, 3. And 6 thousandths. 1, 2, 3, 4, 5, 6. Remember, I will try to make 5 plus 1 or groups of 5 to make it easier to count. This is where the 3 goes. Okay, the 3 is your divisor. And so there are 3 sections. Because when we share evenly, that's what we're doing is we're sharing. So if I'm going to share these 4 by 3, what happens is when we divide, we're going to drop these down so that I'm sharing these 4 as evenly as possible with the 3, which means I get 1 in each section, okay, if I had to fill in the blank. So what do I do with this one? Now let's take a look at what's happening with the standard algorithm. First thing you do, I don't know if you noticed in the notes, but I said write your decimal in your quotient. Yep, step 1, if you're dividing with decimals, just put the decimal in the quotient. This is not just a blank answer line. This is place value positions, and it really matters. And I know this is going to focus momentarily because it loves me and it wants me to be happy. Look at that. Okay, so anyway, so with the standard algorithm, we're going to connect this to this. I have 4. How many 3s can I fit into 4? I can fit 1 3 or 3 individual 1s into 4. So 1 times 3 is 3. And that leaves us, when I subtract, again, use the whole family, so it's divide, multiply. I'm multiplying 1 times 3 to get 3. Subtract and get 1. The compare step is right here. It's an active thinking step. Think about this. I have to have fewer left over here than I have as a divisor. It has to be less than your divisor. Whatever you get here must be less than that, okay? No matter what the number is, this has to be less. So I have 1 left over, and that's where we are. So what do I do with this 1 in the ones place? We know that if I have a number here, 1 of these is worth 10 of these. So why don't we just regroup it with the 2 from the tenths place? So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this is accounted for because I've moved it over to the tenths place. Now I have 12 tenths. 10 plus 2 is 12. So now I have 12 things that I have to divide into these 3 groups. So we're going to take these discs and we're going to evenly distribute them into the 3. So it's a lot of drawing, and I don't expect you to do it, and I'm going to stop right after this. But you count to 12 with these 3. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And as long as you can evenly count and you don't have any extras, you say, we're done. Done with this whole section. They've all been shared. Now, I took my 12, and how many are in each group? There are 4. That's the number that goes here. So 12 tenths divided into these 3 groups make 4 in each group. That's the division step of the division family. Now multiply. 4 times 3, I get 12. Subtract, I get 0. Anytime I get 0, I say, hooray, okay. That means my compare step is easy and I move on. Bring down is the next step in the division family. That's 3. So I'm bringing down 1 digit at a time, okay? Because now I'm doing this place value position. So the next step here is to share what I have here evenly. 1, 2, 3. I don't have any leftovers like I had here, so I have 1 in each group. Now let's show them the standard algorithm. 3 divided by 3 makes 1 for each group. Now multiply. 1 times 3 is 3. Now subtract. 3 minus 3 is 0. Hooray, that makes no leftovers. But I still have, that makes the compare step easy, remember, but I still have my bring down. I have 6 left. In the same way we divided before, 1, 2, 3, and then, of course, 4, 5, 6. These are evenly shared. 6 divided by 3 makes 2 in each group. 2 times 3 uses them all up, and I have none left over. So I don't have any remainders. There's no regrouping. There's nothing up here. So this is the standard algorithm connected with our place value model. Okay, you can write the answer up here, 1 and 412 thousandths. And let's do another one. Okay, just a little bit. Here we go. First thing, let's write each of these discs into the place value positions. 1 in the ones, 3 tenths, 2 hundredths, 4 thousandths. Okay, and this is where the 2 is. This is our divisor. So what happens when I have 2 groups and I only have one that's supposed to be shared? So that will not be able to be shared evenly. So we're immediately going to regroup that. Now, what does that look like in the standard algorithm? Remember to put your decimal up first thing. In the standard algorithm, it looks like a 0. 0 over this number in the ones place because I have 0 here. Okay? Now let's go to the tenths place, which I am going to show you here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that is accounted for because there are 10 of them in the lower place value position. So 10 plus 3 is 13, and look at what we have here, 13 tenths. Sure enough. So let's start sharing these. Now remember, we're counting to 13. So if you need to start distributing, I'm not going to put all the arrows this time. Let's count together. 1, 2, we're counting to 13 if we can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 11, 12, and that's all of these until I get to here. But because this is an even number and 13 is an odd number, how many are in each group? Okay, there's 5 plus 1 is 6. So 13 divided by 2 makes 6 in each group. We're using up 12 out of the 13. And when you subtract, you get 1 left. There it is. So what do I do with this 1 that's left? And I compare and I see, yes, 1/10 is less than 2, so I can move forward with my bring down. I'm going to regroup that 1. And in regrouping, I need 10 of the lesser value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's accounted for now. And I have 12 hundredths. Yes, I do. Standard form says 12. So now I'm going to divide these 12 by 2, putting them into these 2 groups. So how many in each group? Well, let's count to 12. Remember, that's how many I have. So count to 12. So 1, you can slash them as you go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that is all 12 of them divided up. And what happened? I had nothing left over. There are 6 in each group. Take that over to your standard algorithm. 12 hundredths divided by 2 makes 6 in each group. 6 times 2 uses all the 12s. That's the product of what you're grouping here. So it's going to be 2 times 6 makes 12. And then we have none left over, which makes me happy because that's an easy comparison. But I'm not done yet. we still have the bring down. So this section's done. Go back up here, and I have 4 that need to be shared. So we go 1, 2, 3, 4. They're all accounted for. Nothing left over. How many are in each group? 2. That's what number goes up here. 2 times 2 uses all 4 of them, and I have nothing left. So connecting this, and we don't do these forever, this is your future. So really try to understand what's happening here so that you can show it on the standard algorithm. Now, so quickly, just as quickly as we started working with the place value model, we dropped the place value model, so now you can show the standard algorithm. So set it up with a bracket. This is the divisor, and it goes on the outside. This is the dividend, and it goes on the inside. Give yourself lots and lots of room. Okay, don't smash it all together. And remember that this is place value positions. Everything should be lined up. No wavy problems. Okay, that'll be a problem for you later. Okay, so now we're going to apply the standard algorithm because now we kind of understand what's happening. Okay, if I have 3 groups, but I have 0, there will be 0 in each group. Going on to the 7/10ths. Okay, if I have 3 groups and I have 7 items, how many will be in each group? So this is the divide step. You have to think about 3, we know we're going to multiply. So find that missing factor. 3 times what will get you to less than 7? And you might say, well, 3 times, I can't get 7 by multiplying by 3. You have to get less. I was like, I'm playing the Price is Right in my head. You have to get up to the price without going over. If you go over, you lose the whole showcase. But you have to get less than this. So 2 times 3 is 6. And then you subtract, and you have 1 left over. So it's divide 7 by 3, get 2. 2 times 3 is 6. That's your multiply. Subtract, compare. This is less than this, so bring down. Now I have 18 hundredths that I'm dividing by 3, so the division step, okay? Divide 18 by 3. If you don't know, think of what can I multiply, because that's your next step. What can I multiply by 3 in order to get 18? And you might be thinking 6, and you would be correct. Multiply, subtract, and you get your 0. If you get a 0, put a happy face because we are happy that there's nothing left over, and 26 hundredths is your answer. Next one, 4 on the outside, 7.28 on the inside. And my lights went out, but don't worry, because I have a little lamp here now. It's so nice. Decimal up, first thing, if you're dividing with decimal dividends, put that decimal up in there. Now let's start dividing. I have enough here, so how many 4s can you fit into 7? 1, 4. 4 times 1, 4. Subtract, the difference is 3. 3, compared to 4, 3 is less than. So even though it's a lot, it's still less than, which means it's okay. I can bring down the 2. Now I have 32 tenths that I'm dividing by 4. So if you had a place value chart, it would be a lot of dots and a lot of sharing. So think about what number you can multiply by 4. Hopefully you know your times tables. If you said 8, 8 times 4 is 32, I would say nice job for knowing your times tables. Okay, if you get 0 left over, you still have to bring down the 8. 8 divided by 4 is 2. 2 times 4 is 8. There is nothing left over, so put a little happy face and you're finished with that one. So it just becomes a matter of this procedure over and over, that division family. Divide, multiply, subtract, compare, bring down. If you have division, start by putting the decimal up. Now, for each digit in the quotient, or in the dividend, you should have something in the quotient, unless there is nothing out to the left of your ones place. So for the 1, I don't have to put a 1 here because I have a number that will go in the ones place. 17 ones divided by 5 would make how many in each group? 3, because 3 times 5 will use up 15 out of 17 of the place value discs. Subtract, you get 2. Compare that real quick. 2 is less than 5, so bravo, move on. Bring down the 4. It's really 4 in the tenths place. So I have 24 tenths being divided by 5. Now 5 times 5 is 25, but that's too big. We can't go over this, so we have to use 4. 4 times 5 is 20. Subtract. There are 4 left over that we're going to regroup with the 5 in the hundredths place. This comes down, so we have 45 hundredths that are divided by the 5, or 45 discs that you put into 5 groups. So how many in each group? Got to know your facts. 9 times 5 is 45. Subtract and get 0. So you have 3 and 49 hundredths as your answer. Now let's take these skills that you're developing and work on some word problems. Grayson wrote 1 and 47 hundredths divided by 7 equals 2 and 1/10 in her math journal. Use words, numbers, or pictures to explain why Grayson's thinking is incorrect. So let's use the standard algorithm to show 7 as our divisor, 1 and 47 hundredths as our dividend. And let's see if we get the same 2.1 that she got. Now right away, I'm noticing that, first of all, this number that I'm dividing is less than my divisor. So I should not have 2 of anything in here because this is a very tiny number. So I have no whole numbers because 1 is not divisible by 7, and it gets regrouped with the tenths. Now I have 14 tenths. If I was to divide 14 things into 7 groups, there could be 2 in each group because 2 times 7 is 14. When I subtract, I get 0 left over. Hooray! I can now bring down. I have 7 divided by 7, which makes 1 in each group. Multiply by 7, subtract, and get nothing left over. Now my answer looks a lot like Grayson's, but her decimal is in the wrong place. So she, if you want to think about it in terms of too big and too small, and it's very close to lesson, I think 12, where you have to estimate where to put the decimal. Okay, so 2.1 is too big for 1.47 divided by 7. Okay, Grayson needs to shift her digits so that her answer is like 1/10 of this, 1/10 of 2.1. Okay, so it's going to be 10 times smaller. I know that's kind of opposite of what you guys are thinking, because as you get smaller, you don't want to multiply, but it's like 1/10 of, and a lot of people will say it's just 10 times smaller. So whatever works for you, but it's 1/10 of this. Okay, so that's where we are with that one. Mrs. Nguyen used 1 and 48 hundredths meters of netting to make 4 identical mini hockey goals. How much netting did she use per goal? That means for one goal. So if we have all this, and it's going to be split into 4, then 4 is your divisor, and 1 and 48 hundredths meters is your dividend. So set that up and then start your standard algorithm. Is 1 divisible by 4? No. How about 14 tenths? Yes, that's bigger than 4, so I can fit, if I have place value discs, how many would go into these 4 groups. So think about if I have 4 times 3, I get 12. So that's going to use up 12 of the 14. I have 2 left over. Quick compare. 2 is less than 4, so move on. Bring down the 8. 28 now divided by 4. That's the division family. And again, keep this and this handy. You're going to go back to it over and over again. Keep it in front of you. 28 divided by 4 is 7 exactly, because 7 times 4 is 28, and we get 0 left over. Don't forget to click subscribe and come back. I do have some videos from last year on Laura Setness, but I'm not making anything new for that channel. I'm doing all the new videos on Mrs. Setness, and a lot of them from last year I was in a hurry and I didn't put answers, but these I'm trying to give you all the answers in less than 30 minutes. So anyhow, this is your answer, but we do have to label it how much netting, so it's going to be meters. 0 and 37/100 meters of netting per goal. And that's your answer. And then the last one, Esperanza usually buys avocados for 94 cents a piece. It's not $94 because there are no dollars, 94 cents. During a sale, she gets 5 avocados for $4.10. How much money did she save, per avocado? Use a tape diagram and show your calculations. So let's start off with